Okay, so if you read the very last sentence here, it's asking for the values of t where the, whoops, sorry about that, thought I had my pen on, where the velocity is increasing. Be careful. That's asking for where the velocity is increasing. Usually that word increasing means derivative, right? So what this is really asking you for is take the velocity, and to figure out where it's increasing, we take the derivative of that velocity. So what this is really asking for is the acceleration. Okay, I'm going to say that one more time. Increasing, whenever you see the words increasing and decreasing, we usually associate those with the derivative, right? So in this case, it's the derivative of this. Okay, so we're going from velocity, and we want its derivative, which would be the acceleration. Okay, now, if you look at the picture that they give you is the picture, okay, this is a picture of the position. So if we're looking at acceleration, and we have a picture of the original function, wouldn't we look for concavity? So if I'm going to do an acceleration sign chart off of an original function position, I would look for concavity. So I see that I am concave up until I get to 3, and then I'm concave down after. So when the question asks for what values of t is the velocity increasing, that's where the derivative of velocity, acceleration, is positive. Okay, increasing means where a derivative would be positive. So it would be in this interval right here between 0 and 3. Now 0 and 3 isn't in this interval here, so you have to pick the interval that's still positive. Okay, and that would be choice 1. All right, so number 2, I'm going to do a sign chart for the velocity. I'll label it over here, velocity. Okay, so I see that I am negative until I get to 1, right here. And then in here, I'm positive until I get to 3. And then after that, I am negative again. And it is asking which of the following could be the graph for the position. Well, if the derivative, or the velocity in this case, is negative here, that means that the function should be decreasing. And the function is going to be decreasing until I get to 1. And then it starts increasing. So I need to start by going down. Well, this doesn't go down first, this doesn't go down first, and this doesn't go down first. So we can eliminate those as choices. So it won't be any of those 3. Okay, now if you look at these two, these do go down first and these go down first. Now remember, if you look at this sign chart here, do you see that we have a minimum here? So we have a minimum at x equals 1. I don't have a minimum here at x equals 1. That looks like it's somewhere between 0 and 1. But if you look over here, I do have a minimum at 1. Okay, so that would be your answer choice. All right, so 3 I really think is a great question. The problem with it is you need a calculator, and I haven't taught you guys how to use a calculator for these questions yet. So I promise you I will not give you a question that involves a calculator. Okay, so we'll do this one at a later date. So I just finished telling you that we weren't doing number 3, right? Because it requires a calculator, and guess what? So does number 4, but guess what? I'm still going to make you do it anyway. And I'm going to give you some information from the calculator. Listen, what I really want you to take from this is how to do the question. I'll give you the numbers that you would normally get from the calculator. So here we go. This is what I mean. So part A says at time 4 is the particle speeding up or slowing down. Now, you should know, this is what I want you to take away from this, because this is on your test, even though the computations will not be. You know that you should have to find whether V of 4 is positive or negative, and then the same thing with A of 4. You're going to find whether the acceleration is positive or negative. That's the important thing that you need to know. Now, I promise you that on your test, you'll have an equation that would be easy for you to plug in and to find a derivative. Okay, so you're going to take my word on this because I did it in the calculator. This ends up being 2.9787. And then A of 4 is negative 1.1640. Okay, if we have time, I'll show you how to do it in the calculator, but for right now, I just, again, want you to get the concept. So if you look here, you should see that V of 4 is a positive number, but A of 4 is a negative number. Signs are different. So then, to answer the question, we are slowing down. Okay, and that's what I'm trying to get at. So we are slowing down because signs are opposite. Okay? All right, let's go to part B. So it says find all the times in the interval from 0 to 3 where the particle changes direction. So this is the concept that I want to make sure that you understand. When a particle changes direction, first off, you need to find out where the velocity is equal to 0, and then I need to see if we have a sign change around that point. So this is what I mean. So you'd have to have your velocity equation, right? And you would normally set it equal to 0, and you would get your critical points. So again, this is a calculator question, so you can't necessarily answer it, but I'm going to give it to you. I'm going to tell you the point where the velocity is equal to 0 is 2.7074. Okay, now I did this again in my calculator. I'm just going to show you a picture so you can kind of see where I'm getting the numbers from. So when I put that into my y1 in my calculator, this is what I get for the velocity. That's what the picture looks like. And this point right here is that 2.7074. Okay, just can't fit the 4. So if you look prior to this 0, do you see that the velocity is positive? Okay, because it's above the x-axis. So I'm going to put a plus sign right there. And then if you look to the right of this point, the velocity is negative. So I'm going to put a minus there. All right, so this is what I was talking about before. When they are asking when the particle changes direction, first you have to have a critical point, and that was what we found here. And then sometimes, be careful, because sometimes if you have a critical point like this, there's still no sign change. It might go from positive to positive or negative to negative. But because we do have a sign change here, then I know that that particle is changing direction. Okay, and so it says to find all the times. So you're going to write this. Okay? All right, so this question gives you the position function, and it wants to know what the acceleration is. And it does give you a little bit more, but I'm just going to stop. I'm going to read that in a second. But it says, what is the acceleration? So before I even read the rest of this, I want to find the acceleration. So I know that the acceleration is the second derivative. So let me start by giving you the first derivative. So that would be cosine t. And then that would be plus sine t. So there's the velocity. Now let's go one more and let's find the acceleration. So the acceleration would be negative sine t plus cosine t. So once you have that, that's when I want to kind of go back and reread that question really carefully. So it says, what is the acceleration? So we know we're going to use this equation, but let's be careful. At the point where the velocity is first equal to 0. So we have to find out where the velocity is equal to 0. That's going to give us a value of t, and then we're going to plug that value of t in there, okay? Because it's saying at the point where the velocity is first equal to 0. So I'm going to start by taking that velocity, and I'm going to set it equal to 0. So that would give me cosine t is equal to negative sine t. All right, so now you need to ask yourself, what would be the angle measure where the cosine and the sine, I'm going to ignore this for a second, where the cosine and the sine would be equal to one another. And hopefully you're saying, oh, that's 45. Okay, now, I agree to some extent. So I know roughly that it is going to be some multiple of 45, but it's actually not going to be 45 because here, this is a positive and this is a negative. So in that case, really what I'm looking for is where would I have the cosine and the sine have different, sine values, SIGN sine values. So this is what I mean. All students take calculus. Okay. So clearly here cosine's positive and here sine is negative. Now guys, really, couldn't I have moved this over and made the cosine negative and kept the sine positive? So if that's the case, all you need to see is that these guys are opposite signs. And the quadrants that that occurs in is here in the second quadrant, because sine is positive, but cosine's negative. And here in the fourth quadrant, where cosine's positive and sine is negative. So you have two options here. We can get 45 degrees in the second quadrant, or we can get 45 degrees in the fourth quadrant. Okay? However, so we're going to have two possible answers here for t, but actually we're not, because let's go back and read this again. At the point where the velocity is first equal to 0. So which comes first, the second quadrant or the fourth quadrant? And hopefully you're saying it's the second quadrant. So we don't really need to find the angle in this quadrant because this says first equal to 0, which would be the second quadrant. So we need to know what is pi over 4 in the second quadrant, okay? And that is 3 pi over 4, all right? Because in the second quadrant, if the reference angle is 45, then we know that the actual angle is going to be 135, and that in radians is 3 pi over 4. Mrs. Engel also told me, if you had her, that she said first quadrant's pi over 4, second quadrant is 3 pi over 4. She said she taught you this. This is 5 pi over 4. Okay, and this is 7 pi over 4. It goes by odd numbers, 1, 3, 5, 7. All right, so now, this is not the answer, but I'm just going to box it off because I got a lot going on here. So that is the angle. So let's read this again. What is the acceleration of the particle? Here we go. At the point where the velocity is first equal to 0. This is the point where the velocity is first equal to 0. We're going to take this value of t, and we're going to put it in here, and solve. That's what it's asking for. All right, so we're essentially finding a of 3 pi over 4. So we want negative sine of 3 pi over 4 plus cosine of 3 pi over 4. Okay, so negative. Now, the sine of 3 pi over 4, well, please, you need to remember again, what is 3 pi over 4? It's really essentially 45 degrees in the second quadrant. And if we're doing sine in the second quadrant, isn't that a positive answer? So this value will be positive, but we do have this negative that came along for the ride from the get-go. So the sine of 45 is radical 2 over 2, and we know that that value is positive, but again, we have that negative in front. Okay, plus, now the cosine of 3 pi over 4 is also radical 2 over 2. But remember, again, we're in the second quadrant, and we have cosine in the second quadrant, and that's going to be a negative number. So there we go. All right, so then that, we're going to add those. That's going to be negative 2 radical 2 over 2. We can cross that out, and that will be negative radical 2. Oof, that was a doozy, wasn't it? Answer is A. All right, number 6, equation of a tangent line. Well, they already gave you the point right here, so we know what the x and the y value is. So remember, we just do y minus y1 equals m times x minus x1. Now to do m, we're going to have to take the derivative. We did this yesterday in class. So we're going to do f prime of x equals, we're going to do low d high, which is really just 1, right, minus high d low all over x minus 1, that quantity squared. That's supposed to be minus. Okay, and then we're plugging in negative 1 because that's the x value that they gave us. So we're going to find f prime of negative 1. So we're going to do 2, I'm looking up here, we're going to do 2 times negative 1 plus 1, which would be negative 1. Okay, and then minus, and this will be negative 4. And this whole thing will be over 1. And when we work that out, that's all 3. Okay, so then y minus 2 equals 3 times x plus 1. Now that's not there. So if it's not there, let's try to get it to look like it's in the same form as what you see is the multiple choice. So I'm going to distribute. Now I see that my multiple choice answers, they go x, y equals then a number. So that's what I'm going to try to do. So I'm actually going to move the y over here. So that's going to give me 3x minus y. And then I'm going to move that 3 over to the left, which is going to give me negative 5. And that is my answer, which is choice A. Okay, so this is an easy one. We just take the velocity, 2t minus 6, and set it equal to 0. T equals 3. All right, I'm actually going to do number 9 first on this one, and there's a reason why. So we want to see if we can figure out whether the mean value theorem applies. So remember, the first thing that you want to do is you want to look at the function. This is the original function right here. And I want to see if it's continuous, which means let's take this denominator and see if we can find a value for x that would make that denominator equal to 0. So when I do that, I would say, well, x would have to be negative 2, right? Because 4 times negative 2 plus 8 would give me 0. Now, once you get this potential point, well, it is a point of discontinuity, but let's see if it's in that interval. And it is, so we're done. Okay, if this was not in the interval, then we could keep going, but it is in that interval, so we can't keep going. So in that case, we would just say, therefore, mean value theorem does not apply. All right, so I saved the best for last here, number 8. I don't see a denominator in number 8, so if I'm testing for continuity, it's continuous. So check. All right, let's take the derivative. So if I'm doing the derivative, I have y prime equals, that's going to be negative 2/3 times 6x plus 24, and that's going to be to the negative 1/3. And don't forget to take the derivative of the inside, which will be 6. All right, so I'm going to simplify that, and I'm going to do negative 2/3 times the 6, which is going to give me negative 4. And then I am going to take that negative 1/3 power and bring it down to the bottom, and I know that that's a cube root. So there's my denominator. Okay, and there's my derivative. Now, remember, we tested for continuity, and it was fine because there was no denominator. But now the derivative does have a denominator, so we want to see where that is equal to 0. So we're trying to figure out where the cube root of 6x plus 24, sorry, that's not coming out the way I wanted it to, is equal to 0. So instead of cube rooting, let me just change my color so you can see here. Okay, to get rid of that cube root, I would just cube, right? And that would just cancel that out. And I would cube over here also. So that's going to give me 6x plus 24 is equal to 0. And when I solve that, I'm going to get x equals negative 4. All right. So we have a value that makes the denominator of my derivative discontinuous. So in other words, my function is not differentiable at this point. Okay? Do you notice that this point is one of the endpoints of your original interval? If you go back and you look at the mean value theorem, it says that it has to be continuous on a closed interval, which we had, but differentiable on the open interval. So in other words, as soon as I take the derivative and I come up with a value here, okay, this interval here, when I'm referring to the derivative, doesn't have brackets around it anymore. Okay, what it wants you to do is just look at the interval from -4 to -1. That's once you take the derivative when you're testing for differentiability. And so since this value that we have is not in that domain, we're still good. Okay? Yes, I understand the function is not differentiable at this point, but that point is not in that interval because we don't have a bracket here. We have a parentheses, so we can keep going. All right, so then remember what the rule is. The rule is that we take the derivative, which is -4, over the cube root of 6x plus 24, and we set it equal to f of b, which is f of -1, minus f of a, which is -4, all over b minus a. Okay, I'm going to warn you, the computations for this are going to get a little tricky. Will you have the computations like what we have right now? What I'm going to show you? No, you will not. Okay, do you need to understand the concepts? Absolutely. Are you able to do this computation? Yeah, but I just won't give you something so difficult as what you would see here. Okay, for your test, I won't do that to you. All right, so I'm thinking maybe cross multiply. Okay, but before I do that, here's where it's going to get a little tricky. I'm going to plug in f of -1 and f of -4. Now, here's the ugly part, is f of -1, when I plug that in, and you can pause me and work it out if you want, that's 18 to the 2/3 power, minus, and then when I plugged in -4, I get 0, so at least that's easy. But I can't do 18 to the 2/3 power, because remember, this is power over root. And the third root of 18, it's a decimal. Okay, so I'm just going to leave it. It's ugly, and let me just leave it. All right, now, in the denominator here, we're going to have 3, right? Okay. All right, so now let me just rewrite this. So I'm going to have -4 over the cube root of 6x plus 24. And I'm setting that equal to what? 18 to the 2/3 power in the numerator, right? Over 3 in the denominator. I would cross multiply that. So that's going to give me, as ugly as this is going to be, this is going to be 18 to the 2/3 power times the cube root of 6x plus 24. Don't worry about the computations, okay? Because again, this is calculus. We don't really have to simplify. And that's going to equal -12. So then from here, I would just divide out the 18 to the 2/3 power from both sides. Okay, again, don't worry about it. It's all good. And then I am going to get the cube root of 6x plus 24, and that's going to be equal to -12 over 18 to the 2/3 power. All right, now think about before and how we got rid of a cube root. right? We would just do its inverse, which would be to cube. And I'm going to do the same thing here, cube. So that's going to cancel that guy out, okay? And we're going to get just 6x plus 24 equals this ugly mess. All right, and then from there, I would subtract 24 over, right? And then I'm going to divide by 6 as well, right? So let me just write this first. So 6x equals, I've got negative 12 over 18 to the 2/3 power cubed minus 24. And then that value I'm going to divide by 6. Now, again, I understand that that's really ugly. You won't have computations that are so difficult, but the basic idea is what I'm trying to get you to see. Now, just a few more things. So that is my final answer, and I really don't know what that value is because I don't have a calculator. You would have a calculator for this question for sure if the computations were this difficult. But you're not going to on your test, but then again, the computations won't be so difficult. So I worked this out. I ended up getting 4.8 repeating. Okay. Now, I want you to think back, and it's on the other slide. The original domain was 1 to 4. So take a look. This is what we have for a possible C value. And take a look at that interval. So even though we did everything right here, or so I hope anyway, we ended up with a value, but it's not in the original interval that they gave me. So in this case, we do have a C value that doesn't fit that domain, so then our final answer is there actually aren't any values of C. Okay, so you would say no values of C in 1 to 4. And I would just put a line through that is what I would do. Okay, now again, you'll get whole numbers, but if that were to happen, then you just say no values of C in that interval. Okay, you got an answer, it just doesn't fit the interval that they gave you.